How's it going, everybody? Today we are going to talk about conversions and density. So I'll try and keep this short and sweet for you guys. But first, we want to talk about the problem-solving process. So number one, the first thing we want to do, identify the given unit and needed unit, also known as your knowns and unknowns. Okay, write a plan that converts the given unit to the needed unit, also known as setting up an equation. And then identify one or more conversion factors that cancel units and provide the needed unit. So plug in the numbers. Okay, and number four, set up a calculation. So you're going to solve, and then there's two parts to having the correct answer. Okay, you want to solve with the correct units and correct amount of sig figs. Okay, so we are just going to do one just simple conversion. So this is in a radiological imaging, such as PET or CT scans, dosages of pharmaceuticals are based on body mass. If Greg weighs 164 pounds, what is his body mass in kilograms? Okay, so the first thing we're going to do is write down our knowns and unknowns. So what we know is the weight is equal to 164 pounds. We want to convert that. We want to go from pounds to kilograms. Okay. Now, any conversion factor that you would need, I would give to you. I don't think it's necessary to be memorizing conversion factors. I just want you to be able to know what to do with them. So the next step would be to figure out what that conversion factor is. And what the conversion factor is 1 kilogram is equal to 2.2 pounds. Okay. Now, the next thing we're going to do is we are going to figure out where to put what. Okay. So we know that 1 kilogram is equal to 2.2 pounds. We can write that. We can also write that as 1 kilogram over 2.2 pounds, or we can write the conversion factor as 2.2 pounds over 1 kilogram. Okay. Now, when we set up whenever we set up an equation, we want whatever we're canceling out to be at the bottom. Okay. So we want to cancel out pounds. So we want pounds to be on the bottom. So we're going to use this factor here and not this one. So we're going to go 164 pounds. And then we are going to multiply by 1 kilogram divided by 2.2 pounds. Okay. This cancels out pounds. Okay. And then we are going to get 74.5 kilograms. Now, a common question is this. So this right here, 2.2 pounds, that's a conversion factor. That's not a measured number. So we don't use this. The number of sig figs in this number does not affect how many sig figs should be in our answer. We want to look at the actual measured number, which would be this one, the number that was given to us. And so 3 sig figs here, we want 3 sig figs in our answer. Okay? So you don't use the number of sig figs in the conversion factor, you use the number of sig figs in the given from the problem, because that's what the measured number is. All right? So what if we have 2 or more conversion factors? We are going to multiply by those conversion factors one at a time. I want you to separate it one at a time so you can show that where you're canceling out your units. All right, so this one says your new car has a fuel consumption of 39 miles a gallon. Okay, convert this fuel consumption to kilometers per liter. Okay, step 1, we're going to write down our given. Let's choose a new color just for fun. So fun. Ready? So 39.0 miles per gallon. And we want to convert that to kilometers per liter. Okay? So we're going to write down what our 2 conversion factors here are. So miles to kilometers. Okay, there's in 1 mile, there's 1.6 kilometers. Okay, and then if we're also going from gallons to liters. All right, and in 1 gallon, there's 3.785 liters. Okay, so now we're going to set up our conversion factors. So if in 1 mile there's 1.6 kilometers, that can be written as 1 mile over 1.6 km, or 1.6 km over 1 mile. And if there's for 1 gallon, there's 3.785 liters, we can write that as 1 gallon over 3.785 liters, or 3.785 liters over 1 gallon. Okay, so now to cancel these units out, to cancel out miles, I know that I'm going to have to use the factor where miles is on the bottom because it's on the top here. Now to cancel out gallons, gallons is on the bottom here. So I'm going to have to use the factor where gallons is on the top. Okay? So to cancel it out. So I'll show everything here. Now you have 39.0 miles per gallon. And you're going to multiply by, I'm going to do this one first just because I listed it first. I'm going to multiply by 1.6 kilometers over 1 mile. And then I'm also going to multiply. Now, this is going to cancel out miles for me, right? This is going to cancel out miles and leave me with kilometers. Now I want to cancel out gallons too. It's on the bottom, so I got to choose the conversion factor with gallons on the top. So I'm going to do 1 gallon over 3.785 liters. Okay, so then I'm going to get 39.0. I'm going to do 39.0 times 1.6 divided by 3.785 in my calculator. So because it's on the bottom, I'm going to divide by 3.785. And so that's going to give me 16.6 kilometers per liter. Notice this conversion factor had 2 sig figs in it. This conversion factor had 4 sig figs in it. But my answer has 3 sig figs in it because this number has 3 sig figs in it. Okay? Moving on. So we're going to use conversion factors a lot whenever we need to change a quantity for it to agree with another quantity. just follow those problem solving steps. Density. All right, so I just want to talk to you guys about density quickly. We are going to be able to, we're just going to find out how to calculate the density of a substance and what some ways to measure volume in order to calculate density are. Okay, so density, the equation for density is D is equal to M over V. Okay, it's the mass of mass of a substance over its volume. So higher density substances have closer particles that are closer together. So it should look like this. So if I have a high density substance, the particles are closely packed together. Okay, because there's more mass in a smaller volume. More mass, smaller volume. More mass, smaller volume. Okay, and then a low density object would have fewer particles in larger space. So lower mass, higher volume. Okay, so if I asked you to draw a particulate representation of an object with a high density and an object with a low density, the one with the high density, you would just draw a bunch of particles in a smaller space, and then the one with the low density, you would draw less particles in a larger space. Okay. The units of density. Okay. So typically for a solid, the unit of density for a solid is going to be grams per cubic centimeter, and for a liquid, you're going to see grams per milliliter. Okay. And for a gas, it's typically in grams per liter. And the reason for that is, instead of grams per milliliter, is because gases occupy whatever container they're in. And so typically gases will occupy larger containers. For example, we might talk about the volume of this room, for example, and we can't use milliliters for that because that would be a lot of milliliters. All right. Density of common substances. So if I want to know, does something float or not, I'm going to look at the density of water. So I want you to memorize the density of water. It's an easy thing to memorize. Density of water is 1 gram per milliliter. Okay. If I want to know if something floats or sinks, then I'm going to compare it to the density of water. So if it's, for example, copper, the density of copper is greater than the density of water, so it sinks. But if we talk about gasoline, the density of gasoline is less than the density of water, so it floats. Okay. Sample problem calculating density. This is a nice, easy one. I just want to show you the steps that I want you to take. Number 1, I want you to write the givens and the unknown. Okay, so givens are, it says a 0.258 gram sample of high density lipoprotein, HDL, has a volume of 0.215 cubic centimeters. What is the density of the HDL sample? M is equal to 0.258 grams, and it gave me the volume. V is equal to 0.215 cubic centimeters. Okay. And then my unknown is my density. So I'm just going to write D equals question mark. And then I set up the equation. We know that D is equal to M over V. And then step 3, I'm just going to plug in the numbers. D is equal to 0.258 grams over 0.215 cubic centimeters. And I am going to get step 4. The answer is 1.20 grams per cubic centimeter. Now, the reason why I put the 0 there is because I need 3 sig figs. I have 3 sig figs here and 3 sig figs here. So my answer has to have 3 sig figs. All right. Density of solids using volume displacement. So what we're going to do, so when you put something in a liquid, so if I put some zinc here in this liquid, I am going to make a reading of the liquid before I put the zinc in, and then make a reading of the liquid after I put the zinc in, okay? And that's called water displacement or liquid displacement. And that's going to tell me what the actual volume of the zinc is, okay? So in this problem, I really, really love this problem. In the figure below, the water level rises from 35.5 milliliters to 45.0 milliliters after the zinc object is added. Okay, so we're gonna look at this. Here, this is going to tell me the mass, and this is going to tell me what the volume is. So the mass is easy. I can just write down, I know that the mass is equal to 68.60 grams. Don't write 68.6. It went to the hundredths place, so that 0 is significant. This 0 is significant, and you need to write it down. That's important. And then the volume, I have that my initial volume is 35.5 milliliters, and my final volume is 45.0 milliliters, okay? So the volume of the zinc is going to be equal to the final volume minus the initial volume, which is 45.0 minus 35.5 milliliters. I want you to carry your units in every single problem, okay? Just like I'm doing here. And you're going to get, what are you going to get? 9.5 milliliters, okay? And then now we can find the density. What's the density? So D is equal to M over V. D is equal to 68.60 grams divided by 9.5 milliliters. And that's going to give me, I didn't actually do this calculation ahead of time. So 68.60 divided by 9.5, boom, 7.2. And this has 2 sig figs, so I'm going to use 2 sig figs. Even if these two have 3 sig figs, I have to use how many sig figs are in this multiplication problem right here. And there's only 2, or this is division, but there's only 2 sig figs here. So I am going to use 2 sig figs in my answer. So I'm going to get 7.2 grams per milliliter. But because it's a solid, typically we're going to say 7.2 grams per cubic centimeter. Zinc is a solid, so that's what we're going to use. So that's my answer. Do me a favor, people, box up your answers. I like when answers are boxed up. Then I can find what your answer is very easily. So just a quick link to health. So density is really important in identifying osteoporosis. Typically, they'll use scanning micrographs to look at the bone density of older people. Typically, osteoporosis affects older women the most, and when they look at the scan, you can see that these bones are much more dense than these frail bones. So, and bones with higher density, what happens is, and the way that X-rays work in general is that bones with higher density will block more X-rays. And so what shows up on the thing is the bone blocking the X-rays. And that's why an X-ray scan will show you what's going on with the bone. Now, if I break my forearm, then there's going to be an area of very low bone density where the bone is broken. So that's how that works. If I break my bone, all of those X-rays are going to be able to seep through that area where the bone is broken. And then the last problem we're going to do is a little problem using density as a conversion factor. So it says Greg has a blood volume of 5.9 quarts. If the density of blood is 1.06 grams per milliliter, what is the mass in grams of Greg's blood? Okay, so we're going to write down our knowns and our unknowns. We know that the volume is equal to 5.9 quarts. Okay, and we know that the density is equal to 1.06 grams per milliliter. Okay, now the first thing I'm going to do is I have to carry out a conversion factor. Okay, so I need to go from quarts to milliliters. Okay, and I know that 1 quart is equal to 946 milliliters. So I can either write 1 quart over 946 milliliters, or I can write 946 milliliters over 1 quart. Okay, now I'm trying to get rid of quarts here, so I want quarts to be on the bottom. All right, so I'm going to do 5.9 quarts, and I'm going to multiply by 946 milliliters over 1 quart. And that's going to give me 5.9 times 946 gives me 5,581.4 milliliters. Okay, but I only want 2 sig figs here because this is my measured number. Okay, I want the amount of sig figs as the measured number. So in this case, to give this 2 sig figs, I'm going to round this number. I'm going to round this number off, the second number, and I'm going to get 5,600 milliliters. Okay, so now I can say I'm trying to find my mass, right? I know that my volume is 5,600 milliliters. Okay, so I know that D is equal to M over V. I'm going to have to rearrange this equation to solve for M. So I'm going to multiply by V on both sides. Here, this cancels out. I get M equals V times D. And then that's going to be 5,600 milliliters times 1.06 grams per milliliter. Milliliters cancels out here, so that's good. Now we just want to go, we're just going to do 1.06 times 5,600, which is 5936 grams. Okay, now how many sig figs do I want in my answer? I have 2 here and 3 here, so I want 2 in my answer. So I'm going to say 5,900 grams. Okay, And that is my answer. Thank you all for listening, and I will see you in class. Make sure you write down your notes for this and scan and submit. Have a wonderful rest of your day. Oops.